Hello everyone, it's Mr. Grant here. Today we're going to talk about a type of reaction called Friedel-Crafts reactions. These can be used to add a variety of side chains onto an aromatic compound through electrophilic substitution. Friedel-Crafts alkylations are used to substitute an alkyl side chain for one of the hydrogen atoms on an arene compound. Here I'll use benzene as my example, and R is my alkyl side chain. So to substitute in an alkyl group, R, we need a positively charged alkyl group to react with the benzene ring. These can be generated through use of an aluminum chloride catalyst. This creates an intermediate compound, which is shown here, that effectively behaves as a positive alkyl ion. Adding alkyl side chains through electrophilic substitution, though, carries a few potential limitations due to the nature of alkyl groups. Firstly, we know that carbocations are prone to rearrangement. Therefore, when we're dealing with R groups longer than 2 carbons, we have to consider the possibility that it might rearrange and we might get a mixture of products. Here, for example, we don't just get propylbenzene when reacting benzene with propyl chloride. Okay. We also can potentially get isopropylbenzene. Remember that positive charge on the alkyl group could shift to the secondary carbon prior to being attacked by the benzene. That's going to influence where that propyl group ends up bonding. It could bond on either the first, second, or third carbon. A second limitation is polyalkylation. Alkyl groups are actually able to make the benzene ring more electrophilic after they bond due to their ability to contribute to the electron density in the ring. We'll learn about that in a later lesson. But this makes our benzene ring prone to reacting a second time with our electrophilic compound, which would add a second side chain, again giving us an additional product that we probably don't want. So Friedel-Crafts reactions, they're very good for adding alkyl groups, but they're particularly good for adding small alkyl groups where we don't have these limitations. So let's look at one other way that we could deal with these limitations to add longer alkyl groups or other functional groups. Friedel-Crafts acylation is a similar reaction to what we just saw, but instead of substituting in an alkyl group, it substitutes in an acyl group. This acyl group can be later converted into an alkyl group if desired, as we'll see in a bit. An acyl group is essentially half of a ketone. It consists of an R group bonded to a carbonyl, which is then bonded to something else, in this case a chlorine. So this is an example of an acyl chloride, which is used in many types of reactions because its carbonyl carbon is particularly positive. So just like with chloroalkanes, acyl chlorides can be made into strung electrophiles when they bind to aluminum chloride. This effectively forms a positive carbonyl carbon that is open to being attacked by an aromatic ring. This acyl arene compound which forms could then be reduced to an alkyl arene through use of zinc amalgam in concentrated hydrochloric acid under reflux. Unlike Friedel-Crafts alkylation reactions, adding an acyl group does not come with the limitations of rearrangement and polyacylation. The positive charge on the acyl intermediate is restricted to the carbonyl carbon only. Therefore, we don't have to worry about rearrangement group. And unlike alkyl groups, acyl groups actually make the aromatic ring less electrophilic after bonding, so polyacylation is not likely. Okay, so that's all. If you have any questions, please let me know via email or Google Classroom. Have a good one. Bye.